gentlemen. My name is Karim, and right after this session, the session entitled Sustainable and Smart Transport Infrastructure Using Advanced Digitalization. And the session is arranged by strategic innovation program called InfraSweden, which is founded by funded by Swedish Innovation Agency, Swedish Energy Agency, and Foremost. And the aim of this session is to give an idea about how the digitalization is used or utilized to reach a sustainable and efficient transport infrastructure in Sweden. For this reason, we have chosen 4 projects from our project portfolio in InfraSweden with different field of focus, mainly in the infrastructure sector. But before we go in the presentations, I would like to welcome you all and ask you, if you don't mind, just write down your name, the name of your organization, and your country in the chat field. Let's see. Recording in progress. Got it. Yes. And as I mentioned before, my name is Karim, and I am a focus area manager for one of the focus areas called Sustainable Maintenance of Infrastructure, InfraSweden. And before we start our presentations, or 4 presentations, I would like to ask Camilla Byström and Fredrik Lekarp to tell us more about InfraSweden. So, and Camilla Byström is the program manager for InfraSweden. Fredrik is the deputy program manager for InfraSweden, and both have many years of experience from the management of infrastructure, different roles and different positions from different organizations, as you see in the picture in front of you. So please, Camilla and Fredrik, the floor is yours.
Morning. I'm looking very much forward to these project presentations today. InfraSweden is a program with the aim to reach innovations in the transport infra sector. And our method is to finance collaboration projects about innovation of the sector. So we are working with all stages, and digitalization is one of the enablers. And the transport infrastructure, next picture please, is always of great importance, especially in a big country as Sweden. We have large area, have a climate with snowy winters and big temperature differences. So the transport infrastructure needs many improvements. And if we look at what challenges we have in our sector, we have the same challenges and opportunities as many other sectors. Of course, we are dealing with sustainability and digitalization, and we're living in this urbanization world, and the secure going to succeed with the digitalization. And all of our projects must deal with these challenges and opportunities. And they are enablers and holdbacks at the same time. And our main goal is to increase sustainability according to both environmental, economy, and social sustainability. And this is going to lead us into being even more innovative and dynamic and attractive sector. Fredrik?
Yes, thank you. What InfraSweden offers is, first of all, an annual open call for innovation projects, but we also support strategic projects on subjects that are at a strategic level important for the industry, but not necessarily fit in into the open call setup. We have an almost annual innovation competition with possibility for the winners to get funding for additional and further development of the idea. We provide a lot of innovation coaching and competence related support directed both to our projects, but also in general. We organize and co-organize different kinds of seminars, webinars, workshops, meetings, and so on, all in a sense to bring different stakeholders to join forces, to exchange ideas, and to collaborate. The program covers a wide range of subjects. It could be anything from climate neutrality, the circular economy, digitalization, productivity, business models, policymaking, planning, social sustainability, etc., etc. Even though InfraSweden is a national initiative, many of the subjects and issues that we deal with are the same at an international level. So having an international approach has become more and more important for the program. And what we aim in our international approach is for us to keep up to date with the latest development in this industry, and also to find different ways of supporting export and import of innovations. We both seek and welcome partnerships, dialogue, collaborations with international initiatives. We try to find different ways of upscaling the projects that we have supported. And we also offer grants for preparing international proposals and also establishing international collaborations. We have actually an ongoing open call this year. InfraSweden as a program started in 2015. Since then, we have been able to establish about 40 million euros of project investment, out of which 60% is through partner co-funding. And that by itself shows a very good level of interest and engagement from the industry, not the least. We have a portfolio of 150 plus projects and more than 300 different organizations being involved in these projects. The program has a member group of 50 plus, but please note that project funding is not exclusive to member organizations, but as a member, which is free of cost, you'll be able to participate in setting up the agenda and planning of the program and also executing the activities. Now, going from this general information about InfraSweden as a program to today's topic, which is digital technologies. We all know that digital technologies, in many ways, broadly and deeply, are changing the way our modern societies function, and this industry is not an exception. We see a lot of different products, applications, services being developed, introduced, and and used in this industry, even though we have a long way to go before we can talk about digital transformation as a fact in this industry. But many of the projects that are supported by InfraSweden are utilizing digital technologies in one way or another. It could be anything from using smart sensors to collect data, to have big data analysis, or cloud computing models using artificial intelligence, machine learning, digital twin, BIM, Internet of Things, automation, robotics, etc., probably many more type of digital technologies. We see in many of our projects some kind of digital technology being used in order to increase the efficiency of the project itself, and also to advance the industry. In this slide, we have just a selection of some of these projects that are using digital technology. Some of them are using smart sensors to collect data and to improve monitoring of the condition of the infrastructure, or planning process, or executing the tasks on the field. Some are using automation or digital technology. Some are using smart, or making the material smart and connected in order to be able to better monitor the condition of the infrastructure. And these products, services, and applications, they could be about roads, railways, bridges, tunnels, etc. For today's session, we have asked 4 of our projects, as it was mentioned, to be here with us and to present their results, their potentials, and also future possibilities. And but by that, I stopped the general presentation. Just want to say, if you want to learn more about InfraSweden as a program, or you have a question or subject to discuss with us, just have a look at our website, or send us an email, and we'll get in touch with you.
Okay,
Go back to the agenda.
Thank you, Fredrik. Is there any question to Camilla or to Fredrik? Just write down in the chat field, please, your question. One question from me is the possibility for international actors to apply for funds for projects with InfraSweden. Is there any restriction or any conditions on that?
There are no restrictions for international actors to get involved in the projects, but since the grants going through this program are government grants, those grants are exclusive to Swedish organizations. But we have several projects in which Swedish organizations are collaborating with international partners, and the international partners are interested in the project, but they cover their own costs with their own money, or from other kind of grants, or that could be from, for instance, European level, or from a different national program.
Okay, thank you, Fredrik. We don't have any question still. And I just want to remind you also, kindly write down your name and your organization and the country. And if you want us to contact you, so write down your email address as well. So now it's time to dive deeper in the selected project. And the first project is automated construction reinforcement. And this project will be presented by Ulf Håkansson and Lars Pettersson. Both Ulf and Lars have many years experience from research within this field, and also from practical roles in the infrastructure industry or construction industry. And they both are currently working as a technical manager and design manager at Skanska in Sweden. So please, Ulf and Lars, the floors are yours. It's yours.
Thank you very much. My name is Lars Pettersson, and I'm going to present the project that we have named Automated Construction, and in this case, reinforcement. I'm going to present this together with my colleague Ulf Håkansson. We have both been working with this since several years, and I have here a slide showing a picture of me and Ulf. We have both been working with research for many years. And as was mentioned here, we have also experience in design management, and here at Skanska, where we are employed as design managers. We mainly work with what we call major projects like bridges, tunnels, etc. This project has been financed by Vinnova through their program InfraSweden, Vinnova, Swedish Energy Agency, and Formas. Also, our national road administration, road and rail administration, Trafikverket, has been part of the financing, together with our own, the Construction Business Development Fund, SBUF. The partners in this project have been Skanska, ABB, and Husqvarna, 3 Swedish companies, together with consultants Robotdalen and Inodo Robotics. As the name, you can see the name here, they are involved in robotics, of course, both of them. The background for a project like this is our construction activities at Skanska. We see here a tunnel project in the northern part of Stockholm, the capital of Sweden, where we were building concrete and rock tunnels. And on the left-hand side here, you see 3 guys prefabricating reinforcement, which was used for the tunnel that you see on the right-hand side of this slide. They were prefabricating reinforcement, and we noticed that this prefabrication was an efficient way of building, and we could cut construction time a lot, actually. But as you can see here on the left-hand side, the role of reinforcement here, it weighs approximately 5 tons, and it's not that easy just to roll this thing out. We can see here another infrastructure project, a tunnel project that we have recently finalized, a lot of reinforcement being installed. The start of this project was the question, can we increase productivity and efficiency? And you have, of course, seen this type of diagram that we have here on the right-hand side of the slide, with construction actually lagging the rest of the industry, and actually a lot. Some of these diagrams actually show that our productivity is negative, which is, of course, not good. So we started thinking about, can we change this in some way. We also know from several studies that the use of our resources is not that good. We can see this guy here, 30% direct wrench time. Of course, we want that to go up. We soon realized that working with reinforcement, it's also a health and safety question. We can see by these posters here, the guy here working with reinforcement, of course, unsuitable body postures. And this image that we see here on the right-hand side is from a project that we finalized in 2019. Not much has happened here over the years, and health and safety is, of course, a very important question. Can we help in some way? The proposed solution that we brought to the table was a machine using industrial robots to fabricate these prefabricated reinforcement cages instead of the guys that you saw in the image earlier. The whole thing here is supposed to be installed on the construction site, and the reinforcement is supplied to the machine on coils, so they can easily be transported to the site. And what we see here is a cut and bend machine on the left-hand side. So the machine is actually building this. The idea was to develop a machine that could prefabricate reinforcement cages. And in that way, better the health and safety situation for the guys that we have seen in the images, and also increase effectivity on the sites and productivity. By that, I leave the word to my colleague Ulf.
Thank you, Lars. And of course, you ask yourself the question, how is this to be done? I mean, robots have been used in many industries for a long time, especially the automotive industry. And what we have done in this picture is to compare what is the difference between that industry and construction. And the first thing that comes to play is that they have high volume and low mix. That means that they are producing a lot of the same things, and they are doing the same movements all the time. So it's a serial production that you have in the car industry. And it also means that the robots are doing the same movement all the time. And when you have that situation, you then have time to control the robots by programming them. If you then look at the right side, the construction industry, we have the opposite. We have a very low volume and high mix, which means that in this case, we might want to fabricate the same or different rebar cages each time. So there's a very high mix and low volume, sometimes often only one-off production. And this means that it is unique robot movements, and then you don't have time to program the robots. Instead, you have to calculate through algorithms the robot movements by the help of a 3D model, which brings us to the next picture. And then you ask yourself the question, well, what you see to the left, a 3D model of a rebar cage, of course, we have that today all the time. That is how we work today. We do the structural design, and then we make our 3D drawings. But the unique part in our project is that we then use the information that is in the 3D model, and then through calculations with algorithms, we then give that information to the robots. So they they automatically calculate the installation order, the sequencing, and the path planning of the robots. You can just imagine, how does the robot know which rebar to start? Let's say the picture to the left is 150 different bars. How does the robot know which one to start with and which one to end with? And that is all taken care of by the algorithms that we have. I will then show a film that is also on YouTube. You can see the address below. So I will jump a bit into this film after the text, but you can go into YouTube yourself and see the same film. So we have then shown that it is possible to build 2 different cages with the same algorithms. So here you have cage number 1 and cage number 2. So I will jump a bit in this film. And we have 2 robots that are carrying the rebar, and the third one is following and tying with a steel wire, the same tool that is handheld and used today on our sites. You can also see that the movements are like if the robots are dancing around, and that is just to show, or that is a proof that it is not programmed, but that the algorithms are looking for the right path for the robots to move. That is something that we will, in a later stage, will optimize so that the movements are more direct. There you have the tying machine. So we are at the moment using the same algorithms to fabricate a third rebar cage, just to show that it's possible. Okay, so this is the final slide. So what do we have here then? What is the value creation, or the potential value creation? Like Lars said in the beginning, of course, our focus was construction time and productivity. That is a clear benefit with this. We take away manual work, which means that we get a healthier and safer construction site. Also, one should know that the people doing this work today are coming from far away from Sweden, and it's only male that are doing this work, and also rather elderly people. So there are no young people that are interested in this type of work. So it's actually difficult to find labor. By having it automatic and using robots, there's also a gender equality, and we will then have anyone can operate these robots, and it also creates more interesting work that will make the construction industry more interesting. More efficient transport. We will transport the steel on coils instead of each bar by itself, or each cage by itself. By having the model 100% ready in our design, we then get higher quality and we get less waste. We also have a possibility to make a constructability check. Before we start building with the robots, we can check if it is possible at all. And this can then go back to the designer, and maybe they have to do modifications. And the last one is that this is just the starting point. We have chosen rebar cages, reinforcement cages, because it's always on the critical line in our projects. But you can use the same algorithms for any type of construction activity. So the potential is enormous when it comes to that part. And that was the final slide. Thank you very much.
Thank you, Lars. Do we have any questions? Have we any questions in the chat field?
I think we had at least 2 questions.
Yeah, I see. Is it going to increase or reduce the costs? How big the project should be in order for these to be economical? Can this be done on the construction side? The 2 questions.
Yes, I mean, the original idea was that this is not a tool that is in any factory. This is supposed to be an on-site fabrication facility. So it shall be very near the site in order to have more efficient transports or less transports actually. So the transport to the site will be these coils of steel, and then you have a cut and bend machine on site, and then you build it with the robots. When it comes to size of projects, we have discussed that and made business cases, but of course, at least in the beginning, to get these things going, I think you would have to need a rather big project in order to get the interest and the investment, because that is an issue in itself. So a rather big project now. Maybe in the future it can be a smaller project as well.
Okay, and next question is, what can you tell us about the export opportunities? And that was the question I would also like to ask about the how long is to commercializing, or how to pronounce it?
Well, I think
solution.
I think we will see in the future a catch-up effect, that once I mean, this is still a prototype. We have a model in a lab in Västerås, and what you actually need to do is to do a pilot test out on a real site. And after that, I think the interest will be very large. And we have already now been contacted by foreign companies. I'm not going to mention any names here, but very big international companies have shown interest, and they are actually asking us, when can we buy this device? And of course, there is a little bit more work to be done, and then have the pilot to show that it's possible. So, but we are very close to realization. The issue is, like, I think it is a problem in the construction industry, and that is our value chain is very fragmented. So it's a question, who shall take the first step and who should take the first investment? Is it the client, or is it a contractor, or is it the manufacturer? That is still an open question.
Ulf, can you stop the slides so we can see the pictures? Yes.
Great. Are you using vision technology to verify the quality of the final cage?
Not yet. That is something we are looking into, that we will sort of close the loop. So we will have sensors, it could be cameras, it could be some other device that will actually verify that we have built what we intended to build. So that is not there in today.
Okay, thank you, Ulf. And as I mentioned before, if you want to get in contact with Ulf and Lars, please write down your or send us your email in the chat field, and we will get back to you. Yes, and now it's we have the second or the third presentation. And this time will be about iBridge, a project called Digital and Connected Bridge for Efficient and Intelligent Management. And for that reason, we will have Peter Rosengren. Yes, Peter, could you please put the presentation or share your screen? Peter is a CEO for a company called IoT Bridge AB in Sweden, and he has many years of experience from research, as you see in the picture, technical coordinator for R&D, innovation managers, and research director. And yeah, so please, Peter.
Hello, good morning, everyone. I am Peter Rosengren from iBridge, as said. This picture is actually taken underneath the Western Bridge, which is a major bridge in Stockholm, one misty morning in the project. I'm here to talk about the iBridge project. Or I should say that IoT Bridge, we are a company that focus on, we are a small company, as different than Skanska, the previous presentation. We are an SME and we are focused on delivering bridge monitoring system to bridge owners. We were the coordinator of the iBridge project, which ended in August 2021. It was financed through the InfraSweden program and Vinnova. And the background for the project, this project is that the Swedish transport infrastructure is getting older and older, especially the bridges. In Sweden, we have approximately 30,000 bridges. Of these, there are 50% of them are older than 50 years, and 10% are older than 100 years. And this curve is, the diagram is moving all the time to the left. So the situation gets more and more, we get more and more older bridges. That there are two, I would say, two major challenges that this creates. One is the older bridges get more damages over time. That increases the need for inspections and maintenance. Here is some examples of typical damages on a bridge. It could be broken screws. It could be that the reinforcement becomes exposed in a beam. There could be column corrosion. There could also be, depending on the bridge, it could be some damage caused by collisions where a truck might have hit the bridge or a boat, etc. So in general, every bridge in Sweden is inspected every 6 years when a major inspection is done. But depending on the health status of the bridge, it could be every 3 years or even every year. The second big challenge is that when these bridges were designed and constructed, there were also different transport situations. So today, the loads of transports of trucks and trains are heavier than 50 years ago. That is how to make transport more efficient, is to carry more. Also, the intensity and the volume of the transport are much higher than 50 years ago. The climate, change in the climate also changes the condition for material degradation. Now we also have new knowledge and new regulation for verifying the carrying capacity of a bridge. So these were the background for the iBridge project, which we started in 2020, and there were two major objectives. One was to investigate how can sensor technology and new measurement technology, how can that complement and improve manual bridge inspection? Not necessarily replace them, but how can it improve it and make them more efficient? The second objective was to digitize the whole chain and automate inspections and the assessment of the structural health condition in order to reduce the bridge the maintenance and management cost of the bridge for the infrastructure owner, but also for the companies and the citizens involved, having less downtime of the bridges. So this was a truly multidisciplinary project. It was two bridge owners, the City of Stockholm and the Swedish Transport Administration were providing the requirements. iBridge, where we were the coordinator and the integrator of all the software and hardware developed. CNET is an IoT and sensor developer. And KTH was involved as the provided the scientific expertise on structural engineering and did research and developed new algorithms for assessing the lifetime of a bridge, the remaining lifetime, I should say. So in the project, we looked at a number of technologies. There are a lot of new technology developments that are relevant if you want to connect a bridge. Smart sensors was already mentioned. So sensors are getting smaller, cheaper, less energy consuming, and there is a development all the time. So it's not a wild guess that in 10, 15 years time we can, it will be possible to measure anything you want to measure on the bridge. But sensors only provide a lot of data. They just provide measurements. You need also to be able to handle that data and do something useful with it. And therefore there is a need also for new database technology for handling streaming data together with more structured data from maintenance and business-oriented system. The cloud, of course, is very important new technology that allows to both actually to process data on the bridge, but process a lot of data in a centralized location and also store data there. Digital twins is a recent development with many new opportunities for visualizing in 3D and navigating in digital replicas of a bridge structure. This we explored, and we have also AI. Of course, that is machine learning is a very important technology here, which allows us to continuously monitor data being generated by sensors and detect patterns in the large data sets. So, and finally, the smart phones and the apps and new web technology have created new channels to reach out to end users with new type of decision support. And that was the whole purpose of the project. That was to integrate all these technologies and deliver that in a form to hide the complexity of this technology and hide that in one platform with an easy to use interface for decision makers. So that was the result of the project, was a bridge monitoring system, which consists of mainly 4 different features. So there is a dashboard and an app for bridge engineers that need to continuously monitor what is happening on the bridge. If it's a railway bridge, how often is train passing by, how fast are they driving? Is it opening the bridge? Is it how much traffic is going on, etc. Then there is an advanced functionality developed by KTH for assessing in a particular position on the bridge what is the remaining, how much damage is done here, and what is the remaining service lifetime in this position. AI algorithms are deployed for this behavior change analysis, and as we can see Up in the right corner, there is a digital twin that can be built on top of the platform for simulating various aspects. So the platform has all sorts of diagrams, etc. So there are thousands of ways of viewing the data. Directly, actually after the project ended, we were also, we did get also two commercial installations of the platform. So one is in a bridge in the south of Sweden, Vänersborg. That is a railway bridge which is can be opened, and there this is an old bridge, 100 years old. It's called the German bridge because the constructor was actually a German. It is the same guy who constructed the Golden Gate Bridge. Here we have a number, we have 25 sensors continuously measuring at 200 hertz a second. And that has been going on since December 2021. And we have a pretty good understanding of the load on this bridge and how much more it can be used. And the effect of this monitoring campaign is that the conclusion is that this bridge can be used much longer than originally anticipated. In the north of Sweden, there is a second installation going on, which is on the North Botnia railway track. And there, this is a rather new bridge, but the owner have installed dampers on the bridge, and that the reason for that is the monitoring campaign is to see how the effect of these dampers. Can we allow faster trains to pass over this bridge? And there is a digital twin developed that allows us to analyze and simulate different train passages. This is just a short, this is how the dashboard looks. And this is some views from the digital twin. There is on our website, we have a video of this, and I recommend to look at that because that is really, one can see a number of new possibilities how you can use that technology in navigating and visualizing different aspects of the bridge and of a train passage. So to conclude about the impact, so after project end, this is what we see that the impact of this project is that this has for the bridge owner, there is a way of better estimate the remaining lifetime of bridges, which will allow or allows an extended use, but under controlled situation of a bridge. And this means that one can put investments forward, maybe use the bridge 10 more years. And we can also forecast the effect of if I want to change something about the transport, allowing, for instance, higher loads, trucks that are heavier, or if we can allow more intensive railway traffic, how will that affect the lifetime of the bridge? How much will it shorten the lifetime of the bridge? There is also more efficient maintenance that has been achieved, so you can focus on bridges with heavier and more damaging loads and traffic volumes, so that is you can plan your maintenance work better. And there's also a way of early detection of some changed behavior, and that will lead to a reduced downtime of the bridge. So a bridge is always very critical. If you close it, then that creates a lot of costs for everyone in the society. People have to go different ways to work, etc. For KTH, there has been a use of they've been have found new research directions. For instance, use of machine learning for bridge monitoring. There's a lot of research that is now being done there. And also in exploring more and doing more research on how digital twins can be used to reflect the structural health status of a bridge. And
Ja, det går då.
last but not least, it has been a very successful project for our company. We are, as I said, a small company, but now we are bigger. We managed to recruit 3 new employees. We have had a significant growth of our revenues, and we are also experienced international interest. So we have inquiries from both Italy and Greece, which we are discussing now. And this is very interesting because since all of it is most of our system is in the cloud, all the analytics, etc., and data storage can be done from Sweden. All we need is a local partner that can mount the sensors on the bridge, and then the rest can be done from the cloud. Okay, so I think that was my last slide.
Okay, thank you, Peter.
Peter.
Thank you for an outstanding presentation and a very interesting technology or solution. There are some questions as I see here.
Can I just mention that we are a bit behind the schedule?
Yeah. Are the bridge solutions applicable in other countries than Sweden?
Yes, it is. It is. As I said, this is all we need is a local partner that can mount sensors on a bridge, and then the rest of this will be, and then we can do everything from our side here. So yes, it's definitely applicable in other countries.
So it's a commercial usage as a service.
Yes, absolutely.
Not as a technology, and that's what's the answer to the second question. Okay, as we are a bit behind the schedule, then we move to the next presentation. And if you have any question,
Peter, can you stop the presentation?
Let me see, how do I do that? New share, okay.
Yeah,
no?
And please, if you have any questions or any kind of you want to get contacted with Peter, so send your email in the chat field. And okay, we are going to the next presentation, which is given by Andreas Bäckström and Mats Värme. And the presentation is about a project called Forecast-Driven Dynamic Winter Road Maintenance. Andreas Bäckström currently working as a business developer at Svevia, and he has many years of experience within the R&D in the construction industry, mainly with focus on road maintenance, and they've also been a district manager for Svevia in when it comes to the road maintenance contracts in Western Sweden. Matt is a business area manager in BM System and have also many years experience from business development and project management. So please, Andreas and Mats, take the floor.
Thank you. Can you hear me?
Andreas, you need to change the
view.
The view.
Okay.
So
now it's correct.
Great.
And you can hear me good?
Yes.
Okay. Thank you for the presentation. So we're going to talk about our project Dynamic Forecast Control Winter Road Maintenance. And at the bottom of the slide, you can see our financiers and most important project partners. So who are we? Svevia is Sweden's largest road maintenance contractor and service more than 50% of the yellow areas, that is of the state-owned network. And BM System is Sweden's largest supplier of management system for road maintenance contractors and services more than 80% of the state-owned networks, as you can see on the maps at the right. So first, I'm going to give you a brief introduction to Maintenance Decision Support System, MDSS. And there are today several road weather forecast services in MDSS that can provide qualified support to decision makers in winter road maintenance. As a basis, data from fixed road sensors from iBridge stations, that is weather stations, are used, and additional data from mobile sensors. So the services provide dynamic road conditions forecasts and proposals for actions needed for different road sections. So they deliver detailed decision-making forecast that enables high-quality decisions for the correct actions in the right time at the right place. And I'm going to show you a little more about it just in a second. So the main advantage is that forecasts clearly show which part of the road networks that needs to be addressed. So here you can see MDSS system and its functionality expressed through different data layers. And they are surface temperature, road status, and salt recommendations. That is, of course, very useful for the maintenance contractor. And you have a data layer for residual salt that are calculated from the connected spreader data and road friction estimates. So the background to the project is how is it possible to make full use of all of this MDSS data and detailed information in the production? It is really too much information, we felt. So we needed to automate. So why dynamic optimization? It's simply variation in road climatology and weather gives incentive for optimization. But also the time we started this project in 2015, we saw some more new challenges with decreased experience, negative productivity development. Experience in operational winter management is a shortcoming nowadays, which is partly due to more flexible labor market with short contract periods, but also due to major retirements that has been in recent years. So we could see a future with more pressure on inexperienced production personnel and management. So the risk were low competence and attractivity in the maintenance field. But we also saw some new opportunities regarding R&D. We have the MDSS, as I have shown you, but with the forecasts from different suppliers like Vaisala, Klimator RSI, and SMHI, that were connecting the dots, so to say, with algorithms calculating what kind of conditions there were on the road network between the RV stations, the weather station that is. We also got route optimization. In the past, we used pencil and paper to make routes, and today we use route optimizations program. We also have a driver support with mobile apps, with call-out systems. In the past, we called every single maintenance vehicle out by phone, but nowadays we're with one click uses an app to get the whole fleet out. And we also have new navigation possibilities. to get the route optimized digital routes out to the lorry, and to use navigation to navigation functionality. So we thought, what if we bring it all together? So let's connect it all for an IT solution for Dynamics. And now I'm gonna pass over to Mats. Thank you all.
Okay, thank you, Andreas. A little bit about the project aims is overall, we need to make the decision-making process easier. As Andreas said, just looking at the MDS system is too much information, how to use it in an efficient way. So we integrated data from the weather forecasters into existing management and monitoring system that already was in place. And also be able to reduce the error margin regarding communication between the decision maker and the guy actually driving the winter maintenance vehicle. So the conclusion is it's possible to create a more productive winter road maintenance by using technologies that will give you where we can use these dynamic road conditions throughout the system and end up with much higher automation. And it's quite easy when you look at it this way, that every hour a forecast is produced with a high resolution forecast down on small road segments. We inhale this every hour and do an on-the-fly route optimization and creates a suggestion for the decision maker. Do you want to use this scenario? Do you want to do a call out? Where you can say yes, and then it automatically will be sent to the driver out to the gritter, and they can follow navigation system and instructions in the vehicle. And we are actually working right now with fully automating everything from the salt spread as you're actually just driving your vehicle. And we did this and we have verified it, and it works fine. And so all the functionality is in place, navigation optimization, call out, that's good. And what we're working with the most right now is how precise are the forecast. It will never be 100%, but we like to say that, okay, we have built a rocket. What we're doing right now is fine tune the rocket fuel. This is in place. And this is an example of if you compare dynamic work based on road weather conditions on segments and by using optimization with the traditional way of working. So we look in this example, we looked in the contract area of Gothenburg, south of Sweden, and this for a specific weather situation, we had this salt demand. By using optimization, we could create two new routes that could handle the salt demand, and we compared it with what is actually done in a traditional way. We like to call it press the big button more or less every time. So by doing some calculations on a number of different examples, we ended up that we will have a potential between 15 to 25% throughout the year with reduction of salt and emissions and the cost, of course. And 15 to 25 is a little bit depending on where in Sweden you are using this, because, well, we are a big country. And to put it in perspective now, so the winter maintenance is around 200 million euros per year in cost. And we are addressing 30% of that. That's in this picture is named salt. So it's quite a lot of money if we can get a reduction with 15 to 25%. As some conclusions from the project now when it's implemented, we can use the full potential of the decision support system because we can help the decision maker to do it, to make the right decision. We have a decrease in salt usage, less emissions, and of course fuel consumption and cost. And we also find out that by working with automation, it reduces stress for the driver. The more automated, the less the driver need to take care of, focus on driving. And overall, one important thing is that management gets a qualified decision support, as removing the weather from the MDS's maintenance decision support system to the road. And also by using this type of technology, because when you have like a forecast that says ice will be forming on a specific section of the road, it also is when in time will the ice form. And we're using that in optimization to make sure that we are never too late on any road section. So we're working both with the geographical placement of the road sections, but also with the time when, for example, ice is forming. But of course, there are still some obstacles that's slowing down the implementation process. And one of the big ones is actually what we call culture. There's an unwillingness to change. It's a very traditional industry. And also we don't think that we don't have good enough forecast. And that's the basic of the reason for that is very much connected to sensor data, that we need to have more sensor data, for example, on measurements on the moist or the water on the road, type of water, if it's snow or ice and so on. For the moment, it doesn't match the needs from the forecasters to improve the forecast enough. And that was all, I think.
Okay, thank you, Mats. Thank you, Andreas, for outstanding presentation. We have a question from the audience. Will this technology also be available for other companies or exclusive to Svevia?
No, it's available for other companies as well. We are actually running a similar project in Norway together with another customer right now.
So it will be a kind of a service.
Yes, a service.
Yeah. Okay. Where's the system is in operation today? Yeah, Norway and Sweden, I guess.
Yeah, it's Norway is a pilot project that's been started this winter, and in Sweden we have been running this for a number of years in Enköping, close to Stockholm, the contract area of Enköping.
Okay. Are you also using satellite data to improve the forecast?
Well, we are not using satellite data for the moment to improve the forecast, but the forecasters that creating the data that we use in the optimization are using satellite data for what we call the nowcast, just to find out how does it look right now. So it's satellite image analysis that's been done.
Okay. No more question, and well, as we are a little bit behind in the schedule, would go directly to the next presentation. And thank you very much, Andreas and Mats. And the next presentation is a presentation about a project called Tunnel Automatic Crack Detection. And we have 3 colleagues who gonna present this project. Andreas Sjölander, researcher and lecturer at the Royal Institute of Technology, with many years of experience from numerical simulations, structural assessments, and experimental testing and deep learning. And we have also Andrea Assesti, associated professor from Italy, University of Liege. And Andrei has also experience from photogrammetry and remote sensing and computer vision. We have also Valerie Belloni, postdoc from University of Rome, and she has been working with digital image correlations and remote sensing and computer vision as well. So please, the floor is yours.
Okay, thank you. So my name is Andreas, and well, the aim with this project was to create a semi-autonomous inspection and assessment system for tunnels. So I would just like to begin with the reason why. So I mean, tunnels they're an important part of the infrastructure network, and it's also, especially in densely populated cities, it's a popular choice when you want to increase the capacity. So we are, for the moment, building a lot of new tunnels, but at the same time, we have a lot of tunnels that are aging. To keep up or to ensure a safe traffic environment, we are inspecting the tunnels regularly. In many countries, we have a maximum time between inspections that are between 5 and 6 years. Today, however, we are inspecting the tunnels manually. So we are closing the tunnels for traffic, and we are putting down the inspectors. And the purpose of the inspection is, of course, to find defects in the concrete lining or in the rock surface in case you haven't any rock support. The tunnels, they are large, so you normally need some kind of equipment like a skylift or something like that to get close to the surface. And of course, this is a really time-consuming task, and it's prone also to human errors that you are not detecting cracks or other defects. So the solution that we are proposing is that we first are collecting data using a mobile mapping system or a drone or any other kind of equipment that you're driving through the tunnel to collect data. Thereafter, we're using deep learning and training an algorithm to automatically detect defects. In this project, we have only focused on detecting cracks. After that, we're using a combination of photogrammetry and laser data to measure the geometry of the cracks. And as a last step, we're doing an assessment of the risk associated with the cracks. So, Andrea?
Yes, yeah, good morning. My name is Andrea, just without the S. And yes, I will discuss a bit about the acquisition of this data from mobile mapping system. So here on the slide, you can see one of these mobile systems that can run on a railroad, is equipped with several infrared camera, LiDAR sensor, and in general is a very good system to acquire a full digital version of the tunnel infrastructure. This kind of platform, they collect quite a lot of data, and data is quite detailed, as you can see in the slide. We can zoom in the images or in the 3D model that is reconstructed out of this data, and we can try to see all the defects. We are able to see all the defects. But unfortunately, the amount of data to analyze is huge. So if you're going to do this manually, it's taking a lot of time in the office to also analyze this data. So one of the goals of this project was to find an automatic way to detect the crack. And we are interested in the very small crack. So you have to imagine that we have thousands of imagery with a lot of pixels inside, and we need to just label and understand each pixel is a crack or not. And we are able to detect very teeny crack, as you can see here in the image, that are just 1 pixel or 2 pixels wide. And starting from this crack, we have another slide with some example that Andreas can show us. We are also able to detect the cracks and not confuse the crack with similar looking objects that are present in the tunnel imagery, like the gaps between different tiles or metal structure that are similar to crack from a visual point of view. And then an important aspect is also to be able to measure the crack over time. So we are able to repeat the measurements every years or every months, depends on the situation, to check the progression of the crack. Because yeah, we detect a crack now today, but this crack will change in the future. And we are able to do this with a millimetric accuracy. And we are also able to produce a map, a 3D map that is informing about the density of the crack and the dimension of the crack over the tunnel line. And this can help to assess the risk that is involved in the different section of the tunnel.
All right, so what we can see with the possible or the outcomes of this project, I mean, so far we have shown that we are capable of automatically detecting cracks. We have been using data from 3 different tunnel types in Sweden. So, and one of the great benefits is that we can significantly reduce the downtime of the tunnel, the time that you need to close the tunnel for the inspection. The mobile mapping can travel in this project. It's traveling with a speed of approximately 5 kilometers per hour through the tunnel while collecting the data. So the data collection goes much quicker compared to sending down the inspectors. As Andrea mentioned, we can significantly reduce the time needed to detect and also then assess the risk associated with the cracks, since we can do this automatically. Otherwise, it's a really tedious process to go through each single image captured from the tunnel in order to detect and see if you have cracks or not. So we can reduce the time, and we can also reduce then the cost for the inspection and assessment. Also for the owners, I think we can improve the knowledge of the structure of the condition of the tunnel, because from this inspection, you will get a full digital model. So you as an owner, you can also, you can go through the tunnel in your office and you can have a look at the high resolution images. So you can both get an idea of the cracks or defects, but you can also get an overall view of the tunnel. So you can better assess the condition. So with that, you have a better base for making your decision for the planning of the maintenance. So as I said, we've been using data, like a limited amount of data from 3 different tunnel types. We have shown that we are capable of detecting cracks, but I think in order to get this one step closer to an implementation, we need to go a bit further, and we need to make a larger scale, like a proof of concept, to really show that this technique is working. And I think the way to go is that we should inspect tunnels first in a digital way, collecting data, autonomously detect cracks, make our assessment, and then we should make an inspection with humans, just to verify and compare our results. And I think in this way, we can show the time you can save, and then we can also show on the accuracy that we have with this system. And that was the last slide, so thank you.
Okay, thank you, colleagues. Do we have any question here? Yes, we have. Do you also have instrument to look for changes in the rails, distance between them, or track changes? Let me see. Changes head of the rails or only tunnels? So is there any possibility to apply this technology to other type of damages?
It's definitely possible to apply the technology to other type of defect. We already did some tests in some tunnels, also in Italy, with some other data. And it's possible to see now in this project, we mainly focus on crack, because for the type of tunnel that we have in Sweden, but the methodology can be used also for detecting cracks closer to the rails. With the accuracy that we have now with the laser scanner that are mounted on the mobile mapping system, I think the accuracy is not enough to see the changes in the distances between the rails. but there are similar technology that are already used also to check the change of the distances between the rails. And
Okay. Mhm. Is it applied as well for the contact wires?
not in this project, we didn't testing on the contact wires. It's depends on the accuracy that you want to have in measuring the variation of distances between the wire.
Yeah. And the damages, is it possible for damages also? Because this one of the main issues in Sweden is the damages in the contact wires, and it's not the maintenance costs, but also disturbance in the traffic caused by these damages.
We didn't test it, but I think the methodology can be applied to different type of damages. Now we focus on cracks, but it's I think
okay.
it's a general methodology. The one that
and let's go back to the main application. We have a question. What if the surface is covered with the bricks? Does the technology understand the difference between cracks and the connecting edge of the bricks?
I think we had, right, Andrea? I think we had in one of the tunnels, we had some tiles as well. And I think, yeah, it could be a problem that the edges of the tiles, they are falsely detected as cracks. But I think it's a matter of getting enough training data. Or what do you say, Andrea? Maybe you can.
We did have some issue at the beginning with the first AI algorithm to discriminate the space between the tiles or the bricks respect to the cracks. But now in the latest development, we are able to discriminate quite well the crack respect to the bricks or tiles edges. Obviously, it's not 100% accurate. The accuracy is around 97, 98%. So there are still few cases of error, but we are talking about processing thousands of imagery. So you have some small amount of false detection.
So how long is it to a commercialization of the application?
Hard to answer, but I think, I mean, we need, as we said, we need more data. We need to just compare the digital inspections to human inspections, I think, just to convince people that it is working, and also for us to verify the accuracy, to see that we are not, I mean, the important part is that we're not missing any critical cracks. So I think that is a really important step now to go further and to inspect a full tunnel and do a full comparison between our results and inspectors.
Okay.
I think in some way link also to the previous presentation about also changing a bit the culture of how the industry is working today. So this is a bit a step forward. So we need to really be sure that the industry accept to use this digital technology from an operational point of view. So they have to trust the technology, because otherwise, obviously, it's difficult.
Okay, so we are getting back again to the culture issues, obstacles. Okay, thank you. Is there any more questions from the audience? No? Well, I guess that was our ambition for today, to present all those.
We have a few more minutes for questions, if anybody wants to ask any general question or anything. Andreas, can you stop the?
Yeah. Does InfraSweden have an ongoing call or innovation competition with what is the subject? Yeah, what is the subject of the ongoing call, or the next call, maybe?
I can take that. Our annual call for innovation projects always open in autumn, let's say in October, November, and closes in February the next year. So our next call, we don't have an ongoing call for innovation project. It opens later this year. But the subject today, this year, the main focus this year for our program will be circularity, circular economy, in a wide sense of the issue. But the topic will be circularity, and also the topic of the upcoming innovation competition, which will be released in a couple of months, and we will have a winner selected by the end of the year. So all those interested in circularity or circular economy application or challenges or issues in this industry should look at our website to see when the possibilities arise. But we do have an ongoing call, which I mentioned, and that's about applying for grants to prepare an international application, and that could be on different subjects as long as it is along with the program goals and ambitions, and also within the transport infrastructure industry. It is possible to apply for grant in collaboration with Swedish organizations, or if a Swedish organization wants to establish collaboration with international partners, there are always certain costs of meeting and so on, and it's possible to apply for grants to ease that cost for establishing these collaborations.
Good. We don't have any more questions, and I would like to ask our colleague Marta, if it's possible, please put the web address for InfraSweden in the chat, if is there anyone who is interested in having contact and look at the program and the content of the program and the polls. Well, so then let's end the session. Camilla, do you have any words?
No, thank you very much for the presentation. And also thank you, Hafshin, for holding this session today, and for your coming and watching and asking questions about the projects. So thank you very much.
Thank you very much, and have a nice lunch if you have a Central European time right now. So yes, thank you to all the speakers and for the audience, and to give me the opportunity to be a moderator for this session, and see you all soon.